Hi, good morning, everyone. Today we are going to talk about a topic of quantum computing. It's going to change a lot of perspectives that you already carry about computing. And please bear with me if I shatter some of your thoughts and beliefs about the world which we live in. Okay? So before we get into the science, let me talk about some English sentences. All right? The ones which the quantum computing is going to change. For example, we were hearing about compute. We have reached the peak of compute for now. That's how it's going to change. We have reached the peak of prediction. Are we able to predict everything today? The answer is yeah, for now. Are we going to change the way machine learning is going to work for us when we do risk assessments in the future, 2030? Well, we are good enough for now. And here comes my favorite one. All our transactions that we do online are protected just for now. It is all going to be broken. All these barriers that I just spoke about are about to be shattered by this one technology called quantum computing. It's interesting, and I congratulate all of you. You've taken the first step today by attending this talk and getting to learn more about quantum technology. I will take some time in delving deeper into the core concepts, the things that make up uh, this capable technology, but it is up to you how you figure out the applications in real life and then apply it and then join me in the innovation bandwagon that we are all uh, embarking towards. So feel free to foster your curiosity once you're done with this presentation today. Embracing quantum computing technology will empower industries to tackle challenges previously thought were. These quantum computers are not just faster computers. The faster computers are called supercomputers. These quantum computers are ones which are utilizing different concepts of physics to, to enable computational power so that we are not just upgrading our computation, we are making a shift. So understand the difference between upgrade and shift. The upgrade is the faster ones, which are doing it faster, 10x faster, probably the supercomputers which are available today. The shift which is happening because these quantum computers are super efficient. And right now, they are already breaking barriers of speed while they are still in their nascent stage. If we were to compare it with the life cycle of a human being, they're just a toddler right now. Whereas the computational power that we see in examples such as AI, it's already in the 80th year of their age, for example. So you can imagine what is the difference between the lifetime of an 80-year-old versus somebody who's a toddler. So quantum computing is already beating traditional computing or classical computing as we call it by lifetimes. And now slides starting to change all of a sudden. Okay. So I've already given the introduction to quantum computing, but there is one thing which I want to plant with you all today. Why are we changing this? Why was this not the first kind of computing that was ever taught to us? Well, just like all other inventions, we took some more decades to understand the nuts and bolts which go inside bringing this quantum computing to reality. And probably that is why we are now starting to learn and believe the inventors of quantum computing who are utilizing principles of quantum physics to now the latest computers that they have been building up. Is this currently in production? The answer is yes. Most of the large tech companies have built their own quantum computers. They own this technology today. There's a literal arms race going on in the world as we see it, where they are using quantum computers to build new technology, new applications, and break old barriers that were looking at them. I'll give you an example of the way quantum computing works and the magnitude at which it is going to change things. One problem was given to a classical computer. First of all, this entire generation of computers that we know today are called classical computers now. They have become old. So a classical computer took 46 years to solve that one problem. That was a projection. A quantum computer solved that problem in 10 minutes. So imagine the kind of change it is going to bring in into things like drug discovery, into understanding environmental patterns, and understanding our own human body. Because simulating human body and weather patterns is very, very difficult. If you were to talk to a scientist, they would tell you drug discovery is a very highly resource intensive field which takes tons of compute power, millions of dollars, and many, many years. But if quantum computers were to come to life and start doing drug discovery, drugs will be discovered in days, not years, and at a fraction of a cost. Imagine movies being made on the same day as they're released. That's the power of quantum computing which it can bring to life. I've already spoken about the overview. I'll go straight to the science. why why it becomes very, very important to look at the way the quantum computers are addressing the same problems that we are trying to solve. Since I'm talking at a school, I'll take a school example. There are two things which are important in quantum computing world. One is superposition. I'm going to start with superposition. So superposition is the property of electrons where they can exist in both states at the same time. We've learned about bits and bytes. It can exist in 0 or 1 state. These are quantum bits or qubits as we call them. They can exist in 0 and 1 state both at the same time. Depends on where we are observing them from. Okay. So when we, yeah, so that's linear processing and that's parallel realities. And because these qubits can exist in two states at the same time, they are capable of parallel realities, meaning they can actually reach solutions to a problem all at the same time. Let me break that down. If we were to give a problem for a classical computer to solve, it will look at all solutions in a linear fashion. It will go from one solution to the other in a sequential fashion the way it is programmed. In the case of in the case of a quantum computer, because quantum bits can exist in multiple states at the same time, the quantum computer can come out with the solution with all possible solutions all at the same time. And that is the reason it is able to speed up all kind of applications where it is deployed. And that's why you see the parallel realities. Okay, so I spoke about superposition already, but I'll take an example of the school, as I was saying. Imagine a class teacher taking attendance in a class of a student of 50 students. Today, how it happens is, I don't know how it happens in this school, but I would imagine in my times, the teacher would call out names and the students would mark themselves present. And the ones which do not respond are absent, right? That's the classical way of doing things. But in the quantum way of doing things, in the quantum world, the teacher shouts out all the names at the same time. And all the students also respond at the same time. Now, if I were to observe this whole phenomena of the teacher calling out all names at the same time and students responding all at the same time, will I be able to find out which student is there, which student is not there? The answer is no. I will never be sure. And that is exactly the property which qubits display. They are there and not there all at the same time. Be with me. Taking this example a little forward, if I were as a scientist, as a quantum scientist, this is exactly what happens in quantum computers. When I run one simulation or when I run one problem on a quantum computer, when the qubits are observed, that is exactly where they present one state and it is assumed in theory that their state changes at the exact same moment they are observed. Meaning, if I were to now call out one student, so for me, for the teacher, all students exist and non-exist at the same time. But if I call out one student's name, and suppose that student is there in the class, that's one. And by the properties of superposition, I would now say because I've observed that student, I'm sure that that student is there. And because of the properties of superposition, now that student will be absent because I've observed already. Okay, am I making it too complex? I hope not. So these are by virtue of this property of superposition, the quantum computer is solving these problems all at the same time because it does not have to go in parallel, in sequential order. It is doing everything in parallel. Actually, you can never beat a quantum computer at a game, only because of this reason. The second property is entanglement. Entanglement is very simple as compared to superposition. And these are the only two concepts I'm going to talk to you about. Please bear with me. It's getting technical, I know. Entanglement is very, very easy. It simply says that two qubits are entangled to each other, meaning they can be connected to each other, meaning their states are connected to each other. So if one qubit is 1 and the other one is 0, and I toggle this one qubit, the other will also get toggled. So this 1 becomes 0 and the 0 becomes 1. And they may be miles apart. That's the beauty of entanglement. In the student scenario, imagine if I called out to that one student who was present in the class, and because I identified the student, now he's a qubit and becomes absent. The other student who is entangled with the same student may magically appear in another class. That's the property, that's the properties we are talking about. And by the way, all this is sounding like science fiction. It's all true. Our nature is designed in such a way. Quantum physics is a very old field. Even quantum computing is over a 40-year field now. But these machines have been designed now and they have come to life now. Earlier this year, 6th of February 2024, was the first time in my life when I ran my first program on a quantum computer, on a real quantum computer. I hope you get your quantum computer dates very, very soon. And especially the students. I believe that the students are going to drive, the people who are students right now are going to drive the next phase of growth for computing which will come using the quantum computers. I have some applications to talk about. One thing which is very close to my heart is security, cyber security. It offers challenges as well as solutions in the field of cyber security. Number one, as I said before, all encryption that we see today is going to become irrelevant because quantum computers can break any kind of encryption which exists today. So what happens next? We need a good guy. We need a good guy quantum computer to design encryption which cannot be beaten by the other quantum computer. And how do we achieve that? There is already research going on. Even the government of India has allocated 10,000 crores towards quantum mission, where a lot of research is going on. There's academia involved, there is startups involved, there are tons of companies, etc. Things like TCS are involved into research and development of technologies which can be used by industry, the military, the space agencies, all at the same time. The next one, which I would like to talk about, is climate change. It's hard to simulate all kinds of climate action which is going on, and the future it holds for us as a human race. But with quantum computers, we can possibly simulate all kinds of scenarios which we were only able to imagine or sometimes not even able to imagine. Now we will, in our own lifetime, we will see a time when we will be able to predict earthquakes and floods and any kind of natural calamities and save more lives. That's the power of quantum computing. I've already spoken about drug discovery and other technical fields as well. In my opinion, the future is quantum. But let me also bust that myth. It's not going to replace your laptop. Your laptops are going to be there. These are classical computers. These will act as endpoints. These will act as our interface to the quantum computers. You are not going to carry quantum computers in your backpacks, but you're going to carry these endpoints in your backpacks, which will help you connect to the quantum computer and solve your problems. So these laptops are not going anywhere. Our phones are not going anywhere. But the way they process information is going to change forever. Quantum computing is unlocking unlimited possibilities. Are you ready? Thank you.